So this is 9.4, measures of variation. Could I have a volunteer read our learning target where it says LT? Dash?
I can find and interpret the range and interquartile range of a data set.
Thank you. So a measure of variation is a measure that describes the distribution of a data set, so how spread out it is. A simple measure of variation to find is the range. The range of a data set is the difference of the greatest value and the least value. So the range is literally taking the greatest value and subtracting the least, and that tells us how spread out our data is, right? How far apart are the biggest and smallest values. So in example 1, the table shows the lengths of several Burmese pythons captured for a study. Find and interpret the range of the data. So first I'm going to find the range, which is greatest minus least. So my greatest value is 18.5. My least is 5. And when I subtract those, I get 13.5. That is my range. So range is very simple to calculate. It is greatest minus least. But what does it mean? Because that's the whole point of this chapter, is not just to be able to do these calculations, but then to talk about what is this telling you about your data? What the range tells you is how spread out or how varied the data is. So if I have a range of 13.5, that's telling me that the lengths of the pythons that I collected vary by no more than 13.5 feet. What that means is if I pick a length of one of the pythons, I know that the furthest, the biggest difference that there could be from that length to another one is 13.5. There's no bigger difference between the lengths. They all fall within 13.5 feet of each other. That's what this is telling me. Questions about example 1? Okay, just to give another example to give you a little more context, if I asked all of you how many siblings you have, is there anybody who's an only child? Okay, so that means you have 0 siblings, right? Who thinks they have the most siblings? Shelby? So do we have more than 6? That's a lot. So if we found the range of that, we would say 6 minus 0 is 6. That means that the number of siblings that people have in this class varies by no more than 6, right? Some of you probably have 1 or 2 or 3 siblings. None of those are going to be further apart from each other than 6. That's what it's saying. Okay, we're going to move on to our next measure of variation. So before we can talk about that, we need to talk about what quartiles are. So remember quartiles, the word quart, when we hear kind of that, it's meaning 4, like quad or quart, those things are talking about 4. So the quartiles of a data set divide the data set into 4 parts. So the median, what we learned about yesterday, that divides the data in half. That is called the second quartile because it splits our data in half. The first and third quartiles are the halfway points of each of those halves. That creates 4 distinct sections, section 1, 2, 3, and 4. We can then take quartile 1 and 3, here and here, and subtract those to get what's called the interquartile range. So range is how spread out the entire data set is. Interquartile range describes how spread out the middle half of the data is. Because if these are 4 equal sections, there are 2 sections between quartile 1 and 3. That means that is half of our data. So it's going to talk about how spread out the middle half is. The reason that can be helpful is because sometimes we have outliers, right? We have really small or really big numbers. And so if we compare the biggest and the smallest, those might not be descriptions of like the average or typical values. But if we look at what's in the middle, that might be a better description of what most people's answers are. And we can talk about how spread out just the middle part is. So we're going to go ahead and go through an example of that. The dot plot shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. So before I find interquartile range, I have to find the quartiles, which means I have to find the median. What did we learn yesterday that's super important when you find the median? And if you forget about this, you'll probably get your median wrong. Ratisha? Correct. Now this dot plot is already kind of in least to greatest order, which is nice for me. So all I'm going to do is look at the dots and write down what number each dot is representing in a list in order from least to greatest. So 220 would be my first number. Then 230, and since there's 2 dots above 230, I want to write it down twice. Then I have 240, again, that's twice, so 240, 240. Next, I have 245. And I have 250 3 times. 250, 250, 250. 260 twice. And finally, 270. So my data is currently ordered from least to greatest. First, I'm going to find the median, that halfway point of my data. Can somebody tell me, is there one middle number or are there 2 middle numbers? And what is either that one middle number or what are those 2 middle numbers? So 1 in the middle or 2? What is it or what are they? Tanisha? You think 250 is the one in the middle? Which 250 are you talking about? Okay, this one. So one way we can check if that's really in the middle is to count how many are on either side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So because there's 6 on one side and 5 on the other, that can't be directly in the middle. Kaden?
45, 50.
Because if we go in between those, 1, 2, 3, 1, 2, 3, 4, 5, 6 on this side, 1, 2, 3, 4, 5, 6 on that side. So the median is going to fall between those two. Now, I'm not actually going to worry about finding the median. I'm not going to worry about actually calculating it right now because the question asked for the interquartile range, meaning I really want quartiles 1 and 3, and this is quartile 2. The only reason that this is helpful, or the reason I have to do this, is because quartiles 1 and 3 are the medians or the middles of the different halves of the data, meaning I have to split the data in half to find those. So that's the only reason I've started with this, because I need it to be in the 2 halves. So I'm going to start with the lower half here. What is the median or the middle of this lower half? It could be 1 number or it could be 2 numbers. What is the median or the middle of this half? Lizandro?
So I know it's a 1, but I forgot what the word is. Quartile?
It is, but I want to know actually what number or numbers, the median or the middle. Like if this is my data, what would I call the median of this half? Like where would that be at? Grayson? How would I figure out what's in between 230 and 240? Some of you might already know, but let's say it's like we don't know. What can I do to figure it out? Neil? I could, but what could I do mathematically if I don't know what's in between? Emma? Correct. And what is that going to give me? Because some of you probably already knew what it was going to be. Yeah? Because that's what's in between. This is what's referred to as quartile 1 because it is the middle of the lower half of the data. It's the median of that lower half. Splitting a half and half again, right? And now if I do that with my upper half, that's how I'm going to get those 4 distinct sections. That's why they're called quartiles, because these separation points create 4 sections. So now I'm going to look at only the upper half, and I'm going to find the middle or the median of the upper half. What would that be? Or where would that fall? Would it be a specific number or between 2 numbers? Tanisha? Correct. And just like last time, you might already know that's 255, but if you don't, you can add them and divide by 2. This is called quartile 3. It's the median or the middle of the upper half. You can see how these 3 separation points, quartile 1, quartile 2 or the median, and quartile 3, split it into 4 sections. That's why they're called the quartiles. Just a little note. Because our median or our quartile 1, because that was between 2 numbers, that means that our quartile 3 is also going to be between two numbers. Because if we have truly split the data into two equal halves, right, there should be the same number of values on both sides, meaning both sides will either have one middle number or both will have two. Yeah? That is a great question. I was going to show you guys that up on the board because that is the thing that tends to trip people up a little bit. Let's say this is my data, and so the median is that number, right? It's one number. I'm going to split it. So this is my lower half and this is my upper. It's that one number isn't going to go into either half. And then in this case, the middle would be 1.5 and then 4.5. But that's what you do if the median is one number. You just split it through that number and you don't include it with the lower half or the upper half. It's its own little thing. Okay, now I have to actually find the interquartile range, the IQR for short. And right here it says IQR is Q3 minus Q1. So I'm going to take my quartile 3, which was, I just wrote 3 instead of R. I'm going to take my quartile 3, which was 255, and subtract my quartile 1, which was 235. Q3 minus Q1. And that gives me 20. So that is my IQR. And the last thing I need to do is figure out what this actually means. So again, earlier we said the range is describing how spread out the entire data set is. This is describing how spread out the middle half is, because again, there's a quarter in each of these sections, and I'm looking at 2 of the sections, so 2 quarters, that's a half of the data. So this is telling me how spread out that middle half is. So what I could say is that the middle half of the speeds vary by no more than 20 miles per hour. So the range tells me how much the data values vary altogether. The interquartile range is telling me the middle half. So that means if I take any of the speeds in the middle half of the data, none of them will be further apart from each other than 20 miles per hour. At most, they'll be 20 miles per hour apart, but they could be closer than that as well. Questions about example 2? Okay.